Today's webinar. Today we will be looking at solutions with the Fronius GEN24 Plus inverter. I'd like to introduce your Fronius team for today. I'm Ohmpilot, the Technical Sales Advisor for Fronius South Africa. I'm in charge of the Southern Africa region for Fronius. I'd also like to introduce my colleague, Cyprian Okolo, who is the Technical Sales Advisor for Western Africa, and he operates from Fronius International. And I'd also like to introduce my colleague, David Mwangi, who is the Technical Sales Advisor for Eastern Africa, and who also operates from Fronius International. Having a look at today's agenda, we'll start off with an introduction to the Gen24 Plus series. We will then move on to how Fronius became the winner of the HTW, which is a university in Berlin, energy storage inspection. We achieved first place in that study. We will then move on to the PV points on the Gen24. Then going on to the full backup, after which I will hand over to my colleague Cyprian, who will now take you through integration with the Ohmpilot. Also having a look at energy management using the Gen24. We will then look at AC coupling, commissioning of the Gen24, Solar.web simulations, Solar.web configurator, having a look at the Gen24 Plus retrofitting, and lastly concluding with any further information or any questions that are unanswered. Again, I'd like to encourage you all to please ask questions via the question tab, and we'll try our best to answer everything before the end of today's webinar. Starting off with an introduction to the Gen24 Plus series. With the Gen24 Plus, we're going to have two variants. The first variant will be the single phase variant, which will be the Primo Gen24 Plus. It will be in size variants from 3 to 6 kilowatts. Then having a look at the Fronius Symo Gen24 Plus, which will be a 3-phase inverter, hybrid inverter, and its power classes will be from 3 to 10 kilowatts. With both the single phase and the 3-phase variant, they will both have 2 trackers, and they will both have 1 battery input. With the Gen24 Plus, we always try to create products that can last the longest on the market. And one of these attributing factors is the due to the reason of active cooling. So the Gen24 Plus, if you pop off the front cover of the Gen24 Plus, you will be shown a fan in the center of the inverter, which will then be surrounded by a huge heatsink, as you can see in this little picture over here. The objective of this fan is to pull in air from the outside, and channel that air through the ridges in the heatsink, And just beneath the heatsink, you will find the all the power electronics for the inverter. So using this topology, we can really achieve efficient cooling of the inverter. And as you can see by the streaks, you can see the cool air, which is the blue, that gets passed over the ridges, which are quite hot, and you'll then get warm air being passed through the sides of the inverter. This leads to a longer lifespan, a later power derating, and also more yield and faster payback period on the system. Then having a look at the Superflex design, which is something that is incorporated in each Snap inverter as well. Basically what it is, it allows you to achieve a broad DC input voltage range on any 2-tracker inverter from Fronius. So for example, with the Symo Gen24 Plus, it's a 3-phase inverter, and you can basically realize your strings from 80 volts to 1000 volts DC. If you're having a look at the Primo Gen24 Plus, you can then realize the strings from 65 volts to 600 volts DC. So you really have a good range of voltage levels that you can size your PV module strings. And you can also start from very short strings. So you can basically start from strings as short as 3 modules, and you can go to extremely long strings as well because of the maximum DC voltage allowed per string. With the Gen24, we also allow for maximum battery charging and discharging power. So we can discharge and charge a battery with 22 amps. Okay, and obviously depending on which type of inverter it is, we can then achieve full charging and discharging power. So recently, Fronius was awarded the winner of the HTW Energy Storage Inspection for the Symo Gen24 Plus. This was done by HTW in Berlin, which is a university for technology and economics. And the focus of this study was to compare different residential PV storage systems with each other in order to see which is the most energy efficient system on the market. In the study, they used 21 of the most popular PV battery systems on the market. This competition was held in 2020, and it was the third variant of this competition, of which Fronius was able to compete in 2020 due to our new Gen24 inverter. The study comprised various measurement results from different labs in order to do the study, and this is considered an industry-wide comparison. So from Fronius' side, we gave them the Gen24 Plus series along with the BYD battery box for testing. And from that, they were able to give us an SPI, which is a system performance index. So once the study was concluded, it so happened that the Fronius Symo Gen24 Plus 10 kilowatts inverter was awarded the first prize. Okay, and as you can see, we beat all our competitors. And you can see some very popular competitors, and maybe some of these competitors will be quite popular in your markets as well. We beat them all, and we did come out first, and we achieved a 94% overall efficiency. And this is the total system efficiency. So this is your system efficiency with the grid available and with your batteries, charging and discharging your batteries, feeding AC from your batteries, etc. So yeah, we did really good. Again, we were awarded a efficiency class of A, which I will explain what it is a bit later on. But with such a high efficiency class, we can always achieve a maximum yield for the end customer. So with the Fronius Gen24 Plus, we achieved a class A rating, okay? And this was for the 10 kilowatt, 3-phase Symo Gen24 Plus. However, we also tested our 5 kilowatt variant, and we also achieved extremely good results. So with the 10 kilowatt variant, we achieved over 93.5%. And with the smaller variant, the 5 kilowatt, we achieved over 92%. And again, we won first prize for these results. Some of you might ask, what is the system performance index? Basically what it is, in a nutshell, the system performance index states that we take your real cost savings over your ideal cost savings and then give you a score. Okay, so the percentages you saw in the previous slide was the system performance index. Okay, so for example, if we have a residential home with no system, okay, they may be paying 1,500 euros an annum for their electricity. Okay, that's the first picture over here. The second picture is that we now take this home and install PV modules and a PV system onto it. And we calculate before we actually place the system on the household that, look, we can save you 1,200 euros a year. Okay, and this will be your cost savings. This is what you will tell the end customer. However, as we all know, whatever you tell the end customer is not really what happens at the end of the day. Because there's a lot of things that you don't really account for, such as losses in your cabling, tariffs, feeding tariffs, etc. We then have a look at the real system. So the real system is when the PV system is actually installed, and we then go to that system and then have a look at what are the actual cost savings, not the projected cost savings. Okay, and in this example, the actual cost savings was actually 1,100 euros per annum. and the expenses, which could be maybe power that you're putting from the grid. It could be feed-in tariffs. It could be power loss to inefficiencies, etc. And that worked out to maybe 400 euros an annum. So if you take the real, okay, which will be 1,100, over the ideal, which will be 1,200, we then left with a system performance index. In this example, that would give us round about 92%. Okay, so if you looked at the previous slide, okay, the Fronius Symo Gen24 Plus 10 kilowatts inverter achieved an SPI of over 93.5%, which is really excellent if you look at a real world situation. So which losses affect the system performance index? We're going to start off with the control losses. This could be reaction time and switching on and off of loads. So sometimes when there's a very big load that comes online, all inverters will have a very slight delay, but with the Fronius Symo Gen24 Plus, our delay is very minimal. So we can really ramp up quite fast without you having to draw additional power from the grid. The second one being sizing losses. An example of this is low discharge currents and impacts on household loads. So sometimes, for example, when the grid is not available, okay, and there's a very big load that comes online, some inverters give you a very low discharge current. Okay, so that load can't really, come back online compared to with a Symo Gen24 Plus, where we can give you extremely high discharge currents available. We also have to look at your conversion losses, and this is the limitation of efficiency and generation of heat losses. As you all know, PV systems do suffer from heat losses, and with the Symo Gen24 Plus, we've really tried to minimize that with our protocol of active cooling. Then we also have your standby losses, and this is in standby mode. So when an inverter is not producing any power, generally goes into standby mode, and when it's in standby mode, it will obviously consume some power. It could be 20 watts, it could be 30 watts, but that is also something that you do need to take note of. Also having a look at the energy management losses. So for example, when there's a feed-in limitation where maybe you can only feed in 70% of any excess energy you produce, or maybe if you live in a municipality that doesn't allow you to feed any energy to the grid. Yeah, that would all fall under your energy management losses. So if you look at the Fronius Gen24 Plus, the 10 kilowatt unit, okay, this is indicated with this red block over here. This green in the red block indicates our system performance index score, which I told you early on, which was over 93.5%. So we've rounded it off to 94% in this figure. And then if you look at the remaining 6%, these were all the losses. Okay. So for example, the greatest loss was the dark gray, which was your sizing losses, followed by the conversion losses, control losses, energy management losses, and standby losses. If you look at the Fronius Gen24 Plus, we still outperformed our competitors when it came to the SPI, which, as I showed you earlier on, Fronius did come out first and beat many well-known brands out there. So I really like to show you our energy efficiency chart of the Fronius Gen24 Plus. So as you know, with the hybrid inverter, we usually have 4 conversions. We have PV to AC, we have PV to battery, we have AC to battery, and then we also have battery to AC. So if you look at the Fronius Gen24 Plus series, if you're looking at converting PV to AC directly, we have an efficiency rating, which is tested by the HTW Berlin, which again is an independent university, and they gave us a result of 97.6%. Okay. If we then have a look at our PV to battery conversion, we then get a rating of 98.2%. Then having a look at the AC to battery, so that's when you're using AC power, maybe from the grid, okay, to charge up your batteries. With that, we have 96.9% efficiency rate. And then the very important one, which is from your batteries, your AC, we have an amazing value of 97.3%. What does this mean in direct comparison? So from the previous chart, I took 2 systems. The first system being the Fronius Gen24 Plus, which is indicated as G1. And then I also took I1, which is a very well-known competitor on the market. Okay. We compared these 2 inverters in terms of the SPI performance index, and to actually see how much you actually do save in the long run. What's very important for an installer to realize is that, if comparing two systems, you always need to take into consideration what would be the actual cost in the long run, or the cost savings in the long run. So with the Fronius GEN24 Plus, our losses per annum was around 471 kilowatt hours, based on a 10,000 kilowatt hour annual energy consumption profile. Compared to the system, which lost around 1,079 kilowatt hours per annum, this led to a direct saving of 608 kilowatt hours per annum, okay, which is really an incredible value. If you look at the cost of electricity, which, let's say as an example, it's about 20 euro cents per kilowatt hour, this would translate to a direct saving of almost 122 euros a year. If you take that over a 10-year period, that's going to give you a direct saving of over 1,200 euros. Okay, so as you can see, you really do save a lot in the long run with a Fronius GEN24 Plus inverter. Now moving on to the PV points. What are the advantages of PV points? The first advantage of the PV point is that it can give you a 3 kilowatt output when there is no grid available and when you have no batteries installed, as long as you have PV irradiation coming through. We allow for extremely easy installation and setup of the PV points. And with a PV point, it allows for automatic switchover, so you do not need to install any additional backup box or disconnection box. This is due to the fact that the PV point is actually a separate outlet on the Fronius GEN24 Plus inverter. Again, the PV point is free of charge with the GEN24 Plus, so it's nothing additional that you do have to add to your order of the GEN24 Plus. Just to give you some technical facts of the PV points, the PV point can give you a maximum of 3 kilowatts output, single phase, okay? It doesn't matter which GEN24 Plus inverter you purchase, it will all give you an output of 3 kilowatts in emergency mode, which is backup mode, which will be single phase. However, we can give you an output of up to 4.1 kilowatts for around about 5 seconds. And this is good if you want to start up any loads, for example, such as a motor that maybe has a very high startup current. The PV point will only be supplied in the case of grid outage, okay? So when the grid goes down, our GEN24 Plus will also go down, okay? The reason for this is that we always do checks, and we do the low voltage ride-through checks. And because we have so many country setups on our inverter, we have to make sure that we do the specific country checks to make sure that it's safe to go offline, okay? And also when we come back online, we'll also always do our tests to make sure that it's safe to come back online, okay? This is the very reason for our, let's call it our shutdown time of about 60 to 90 seconds, after which we will come back online again. And after that period, we will then provide you with an output of 3 kilowatts single phase on the PV point, as long as you have PV power available. Again, you do not need any additional installation. So this is really cool because you do not need to install a DC disconnection box, okay, whenever you're going to make use of the PV points. And again, you do not need to install batteries when you're using the PV point. So with the PV point, it really provides the end customer with a really cheap alternative to get into some form of backup power without the need for costly batteries. And as you all know, Fronius is the only manufacturer on the market that can do this. They can provide you backup power without batteries. That's another thing to take very important now as well. So when it comes to the installation of the PV point, it's very simple. On the actual GEN24 Plus, we have a separate outlet on the inverter, which is dedicated for the PV points. So this outlet, as you can see, you will have your neutral, and L1. Your L1 and your neutral will go to your load, whereas your other neutral will then be earthed to the earthing of the inverter. The only thing you need between this outlet and between your loads should be a socket with an integrated RCD, or you can have a socket with an external RCD. And the RCD, which is your residual current device, we recommend that this RCD should be 30 milliamps rated. And that is just a safety feature. What you also need to do on the Gen24 Plus is that you just need to drill a hole on the cable inlets for your outlet for the PV points. When it comes to Solar.web, your display of PV point will also be shown on Solar.web. So for example, when the grid goes down, you'll get this device state on Solar.web, which will indicate that, look, your PV point is in operation and you have an X amount of power going to your load. Now moving on to full backup. Full backup is only available with the Gen24 series when you have a battery installed. Okay, when you have a single phase Gen24 Plus, you can get single phase backup. If you have a 3-phase Symo Gen24 Plus, you get 3-phase full backup. So when the grid goes down, our Fronius Gen24 will also go down with the grid for about 60 seconds. It will do all its necessary safety checks. It will also send the required signals to the backup box in order to make sure that it's a safe disconnection from the grid, after which it will then come back online and then supply your loads with full backup power. Which batteries are compatible? So as of the moment, the only compatible batteries will be the BYD battery, Premium, HVS, and HVM. These batteries are actually quite easy to get hold of, especially in sub-Saharan Africa. The reason for this is that BYD has established a company called AfriPlus in South Africa that basically have become the distributors for BYD. And through that, they've also established many sub-distributors in Africa. So again, it's not difficult at all to get hold of these batteries. And with these batteries, they're going to come in 2 variants. They're going to come in the BYD battery box Premium HVS, which is already available in sub-Saharan Africa. And it will also come with the BYD battery box Premium HVM, which is not yet available in sub-Saharan Africa, which, however, in the next few months will hopefully be available as well in sub-Saharan Africa. What's very important to note with the HVS and the HVM, there's different size variants which are compatible with either the Primo Gen24 Plus or the Symo Gen24 Plus. So if you're looking at the Primo Gen24 Plus, the minimum battery storage you can start off with is 5.1 kilowatt hours. Okay, basically what that is 2 of these gray boxes with 1 black box on top. The black box is basically your BMS system, which is your battery management system. So you can start off at 5.1 kilowatt hours. If you then decide in the future that, look, you need to upgrade to 7.7 kilowatt hours, you then need to purchase 1 gray box from BYD, and each gray box is about 2.5 kilowatt hours. You then plug off the BMS box, and you then add this new box onto the existing 5.1 kilowatt hour system. So when it comes to upscaling, it's extremely easy to increase the system size. And what's also is really cool is that you can have 3 of these towers in parallel. So in essence, if I purchased a Primo Gen24 Plus inverter, and if I decided I want to have 3 of these HVS 7.7 towers in parallel, I could do that, and that would give me a total storage of around about 23.1 kilowatt hours. Okay. So just remember, it doesn't matter whether it's the HVM or HVM battery, there can be 3 of these stacks in parallel. Okay, that's the maximum you can go. So when it comes to full backup, it's very important that we do it correctly. Okay. The reason for this is that when it comes to full backup, the Fronius Gen24 Plus on the output shares the same output as with the grid. Okay. Just to make more sense of that, let's say that we have the grid available. Okay. We have one output that is connected to the grid and which is also connected to the loads. Okay. When the grid goes down, that same output needs to be prevented from sending power to the grid. Okay. What do? We need to install a backup panel. Okay, this is very important. This is the only additional component you need for the full backup. Okay, as well as on top of your batteries. Okay, this backup panel is controlled with 12-volt signals from the Gen24 Plus. And basically what the backup panel is, it's a bunch of NC and NO contacts alongside with a Fronius smart meter. The Fronius smart meter, again, is also very important for the system, and it communicates with Modbus RTU with the Gen24 Plus. Okay, so when the grid goes down, the backup panel will get notified by the Fronius smart meter, after which the backup panel will then open its contacts, and this will ensure that we have no power fed back to the grid. With the backup panel for the Primo Gen24 Plus, basically what it is in a nutshell, if you look on the top, this is the communication port of the Gen24 Plus, and this is basically the pilot card in the Gen24 Plus. On the pilot card, we have a bunch of outputs, and we also have a 12-volt supply, and we also have ground as well. And these contacts are connected to the backup box, which I showed you earlier on. So with the single-phase Gen24 Plus, what's very important to note is that we're going to need a relay, okay, which is indicated as K3 in this image. And basically what this relay is, it consists of a normally open and a normally closed contact with a 12-volt DC coil, okay? So again, it receives its power from the pilot. Okay, that's where the 12-volt, that's where the 12-volt coil receives its power from. Okay, we also have the existing main switch, okay, and this is from your supply grid. This is an existing switch. We also need to install the Fronius smart meter, okay, which goes in your feeding point. That's very important. Again, your Fronius smart meter is needed to control the entire system, and also the Fronius smart meter is very important as it also measures when the grid voltage starts to start dropping. Okay, as you know, if there's load shedding, your grid voltage will start dropping, and our Fronius smart meter will be able to detect this and then tell the Fronius Gen24 Plus to please stop feeding back power. Then having a look at contact K1, this will be two normally open contacts, okay, which will be supplied with two 30-volt AC. So those will be supplied by the grid. They'll be grid connected. Okay, so this will be your setup for the Gen24 Plus. Then having a look at the setup for the Symo Gen24 Plus, because now we're dealing with 3 phases, you now need a few additional components in the backup box. So having a look at the relay K3, we will now have a normally open, normally closed relay, which will be supplied with 12-volt DC from the pilot card. We also have a Fronius smart meter, which in this case will be a 3-phase smart meter. And additionally, we'll also have contactor K1, which will compose of 3 normally open, we have 3 phases, and 1 normally closed, which will be powered by the grid, 230-volt AC. Before I hand over to my colleague Cyprian, I'll please like to launch a poll. I really appreciate if everybody could share their inputs. Okay, the question is, what ratio of kilowatt peak, okay, which is your output inverter power, to kilowatt hours do you install? Okay, kilowatt hours would be your battery storage. Okay, so is it a 1-to-1 ratio? So with 1-to-1 ratio, it would maybe mean 1 kilowatt peak to 1 kilowatt hour of battery storage. Or would it be a 1-to-2, 1-to-3, or 1-to-4 ratio? Okay, I'm going to keep the line open for another 20 seconds. So again, please do share your answers. Okay, thank you for sharing your answers. I'm now going to close the poll. I'd like to also share the results from the poll. So I think it's really cool to see that the majority of today's installers that are watching this webinar actually do go for the 1-to-2 ratio, which again is probably the most popular ratio we do deal with in sub-Saharan Africa. But we also do see that a good deal still go for the 1-to-1 ratio as well as the 1-to-4, and then least the 1-to-3 ratio. Cyprian, I'd now like to hand over to you. Could you please come online?
Yes, thanks a lot, Mo, for your wonderful presentation. As I await, okay, so I believe we can all see my screen now. Mo, can you please hide the poll results so that I can start with, have my screen showing? Okay, great. Thank you very much. So we shall be continuing with the energy management solutions. And yeah, so what do we mean by this? So basically, energy flow management with the solution provided by Gen24, Fronius Gen24 Plus INVERTER. basically entails the analysis, redirecting or channeling, and utilization of surplus or excess energy for immediate or later use. That's simply put. So basically, it deals with the consumption analysis, production of course, and consumption analysis, which is made possible by a monitoring device and a Fronius smart meter, and then followed by intelligently managing this load, the loads we have, and then of course storing for later use. So we will be discussing this in the subsequent slides. Good. So how is this made possible in the first place? This is made possible through our 4 digital outputs that are already integrated in the Gen24, Fronius GEN24 Plus inverter, and they're already available, and of course available for free. With this outputs, you can have the possibility of charging your EV, preparing hot water by the use of our Ohmpilot or heat pump, of course, controlling the pool pump, for example, and of course, in tropical and temperate region, this very well comes in handy in terms of using the air conditioner. So with these 4 digital outputs, you can be able to intelligently monitor and control these appliances. So let's go further and see how this is done. So on the communication interface, which we preferably call the pilot, that's the communication interface of the Fronius GEN24 Plus inverter. That's where you can now find these 4 digital outputs that can be used. And each of the 4 digital outputs, they output 12 volts DC. So that's the signal that they output for actuation of any of the loads that we want to control. So as you can see them explained in these boxes, so we have IO0 to IO3. So these are the output. They are basically input-output ports, but they are preferably used as output ports, and they are for IO0 to IO3, as earlier mentioned. Good. So how is this wired or actuated per se? As I have already mentioned, we have input-output ports 0 to 3. So they are already implemented as output ports, as earlier mentioned. So in order to activate a load or any load that you want to control, you would have to use an external relay. So this external relay, as of course, obviously would be a 12 volts relay, because that is the same signal that is outputted by the output of the terminal here. So this 12 volts activates the relay, and then the contacts of the relay now triggers the device or the appliance you want to control, be it the EV, be it the fuel pump, or air conditioner. So that's basically how it works. Of course, you can attach a manual switch to have a manual override in case you want to determine by yourself what time you want to use these appliances by yourself. Good. So this is basically for a single-phase solution. So if it's a 3-phase solution, then the same thing would apply appropriately, of course. Good. So basically, the components you need to have this solution is, of course, your Gen24 inverter, and then the smart meter, which enables you to analyze and have a full overview of both your consumption and your production details. Then, of course, the trigger device, which is a 12 volts relay. So with this, you can be able to intelligently manage and operate your loads. Good. So taking an example of an EV charging for a particular client who comes home from work, let's say about 4 p.m. as indicated here. So he comes home and then plugs in his EV for charging. And at that point, as we can see here, the charging power actually rises to the maximum charging power, which is about 11 kilowatts. So this, of course, comes with an increase in tariff, because this period tends to be a peak period. So he not only pays for the regular tariff charge, he also pays for peak period charge. So in order to curb this, he can use the Fronius output ports to control his charging. By so doing, he will be able to utilize the surplus energy generated by PV. So how this is done is that it intelligently manages this load, and instead of taking this short period that costs him more in terms of peak period charge, he can utilize the surplus energy generated from his PV and then charge the EV to maximum point, but in this case, a longer period by charging with about 3.6 kilowatts charging power. So this makes a lot of sense because he ends up not being charged for peak period usage during, as you can see in this case, without an intelligent control. And even in the case where night falls and then there isn't enough PV, as you can see in this case, of course, nighttime charging can then be implemented, which is, of course, not a peak charging period. So this is how you can intelligently control a heavy load, as the case may be in this example, an EV. Okay. So in terms of implementation or activation, this is made possible with the new Fronius Solar Start app. So once you have it installed, you can go to your settings and then go to load management. There you can now activate the pins that you want to use to control the load. In this case, as you can see, we have, as earlier said, 0, 1, 2, and 3 output ports. And then you can now select the one you want to use and then, of course, have them configured for use. So once this is done, as you can see in this example, pin 1, for example, corresponds to output port 0. Pin 2 corresponds to output port 1. And then subsequently 2 and 3 corresponds to pin 3 and 4. So when it comes to setting these loads, we need to set the thresholds. The thresholds are basically operating windows. In this term, we mean the on and off period. And this can be done either by power production or by power surplus, in which case is the most popularly used, because it's preferably when you have surplus power, then you would want to maximize self-consumption and then use the surplus energy to activate other loads or use it for other purposes. So in this case, you can now set your on and off operating modes. And this is basically done, of course, using your load analysis, and then you can now set it to your preferred power limit. So let's take, for example, let's take a 2 horsepower AC, a 2 horsepower air conditioner. 2 horsepower, basically, it's about 1,500 watts, thereabout. Yes. So you can set this threshold such that if your feeding gets to 1,500 watts, it automatically turns on the air conditioner. But then in the long run, at some point, if a heavy load, for example, let's say a deep freezer is turned on in the house, that any load at all that makes the total consumption rise up to 1,000 watts, that determines that that's the point where the operating mode of this particular device, that's the AC, goes off. So this is basically an idea or a way, or one of the ways you can actually set this. So it all depends on your load specifications and how you want to achieve this. So this is basically an example. So delving deeper into it, like I said earlier, you can set it by power production or by power surplus. In this case, power surplus was selected. Like I told you, it's usually the preferred case. And then you set the thresholds. For this example, 2,000 watts was selected. And then consumption off point is a consumption of 500 watts. And then there are also other settings you can actually activate. Yes, you can activate the duration, minimum and maximum duration of operation per day. So in this case, what would come to mind easily is a pool pump. A pool pump conventionally tends to take about an hour to pump. So you can actually set a minimum or maximum period of operation per day. So if you set 60 minutes, the pool pump will operate for 60 minutes exactly and not more. Good. So you can also have a desired duration per day. So that can be set at maximum of 360 minutes, which is about 6 hours, which is of course come in handy when you want to carry out night charge. Let's say for an EV, for example. So you can start charging and then stop charging at 6 a.m. That's of course when you want to leave for work. So this ensures that your EV is fully charged and ready for you to use for the day. Great. So let's have another example. So in this case, we're going to be applying all the conditions that I have stated earlier. So let's take this case, this example where at 7 a.m. when the sun is up, and then you have start having PV generation. Of course, the battery starts charging, and then at about 8 a.m. the threshold for the pool pump is reached. That's about 1 kilowatts. So the pool pump starts operating and then turns off. In this case, or in this example, at about 11 a.m. So when this happens, it turns off at this point, and then at about 10:30 or so, the Ohmpilot comes into play, which we're going to look at in a very short period. So the Ohmpilot comes into play, generates hot water, and once the desired temperature has been reached, it turns off at about 2 p.m. So after this, you can see that we still have surplus energy. So this, of course, is left unused by the client or the owner of this system. So what can we do in this case? Of course, let's see how we can take advantage of this surplus energy in this next slide. So as you can see in this next slide, we have the total PV generation for the day optimally used. So how this is done is same thing applies as the previous slide, but then in this case, at usual time when the threshold for the pool pump is reached, it turns on and turns off at the same allocated time. But then in this case, we can see that charging of an EV have actually been integrated into this setting. So the threshold for the EV charge is 3 kilowatts. So once that is reached, the car starts charging. Also at this point in time, and at the same time, the battery is also being charged. So when it comes to about 2 p.m., the battery is fully charged, and then you have the rest of the power surplus to use in generating hot water. So as you can see in this case, the whole PV generation for the day has been optimally used. Good. So what is really the motivation for the use of PV power for heating, if you might ask? This is basically because of the fact that about 70 to 80% of heating power usually utilized in the residential system, and then of course to get lower feed, because of lower feed-in tariffs, because unfortunately the feed-in tariffs are way lower than the electricity tariff that we pay for. So because of this, we now saw an opportunity for self-consumption. So when is, can now ask the question, when is heating or cooling with PV economical? It comes in a very economical fashion when the feed-in tariff is lower than the price of gas. In this case, you can see approximately 7 cents per kilowatt hour. It is also economical when you have high electricity prices, when you have feed-in limitations, and then if you're using heavy loads like boilers, heat pumps, infrared heating, and of course, air conditioners. And of course, it comes in as a very economical option for countries with high temperatures and mild winter temperatures. Good. So that is where we now introduce the Ohmpilot as one of the solutions that you can get using the Gen24 Plus inverter. So this is basically utilizing surplus energy to heat water via OHMIC loads. So this is basically for OHMIC consumers, as one would say. So how is this done? It is done by activating, the Ohmpilot activates OHMIC loads such as underfloor heating devices, infrared panels, and then of course heating rod in a boiler, which is something as a very, very popular item in this case. So taking that as an example, we can have a situation where we have power being generated about 1,500 watts. So the total load consumption in this case, or in this example, let's say it's about 1,000 watts. This leaves you 500 watts to feed into the grid. That is for countries where this is allowed. So, but in this case, instead of feeding in 500 watts, knowing fully well that you're going to buy back this power that you're feeding in later at a higher cost, why not use it yourself and then store this energy for later use? So in this case, water comes in as a very, very cheap source for energy storage. So in this case, instead of feeding in 500 watts, you can now rechannel it to heating the water so that you can have hot water for use later on during the day. So that is where the Ohmpilot comes in very handy. So it is the device that actually handles the communication and activation of this heating device. So let me go back and then just replace some of the materials or required components. So all that is required is the Fronius inverter with the data manager. That is for conventional snap inverters. But in this case, since we're dealing with the Gen24 Plus, all you need is your pilot, which serves as the data manager for the Gen24 Plus inverters. Of course, you need your Fronius smart meter, the Fronius Ohmpilot, which is the active device in this case. The sensor, temperature sensor, comes in as an optional device, and then of course your heating element, which is the heating rod. Good. So you can actually have two ways you can have this implemented, either with heating rods that are already integrated into the hot water tank. So in a case where you have 100 to 300 liters capacity hot water tank, you can have 1 or 2 heating rods integrated. And then, of course, temperature sensor, which is optional. This, of course, gives you a clear view of the temperature of the water inside the hot water tank. And then, yes, so once you have this, the heating rod automatically starts heating this water with the surplus energy obtained from your PV generator. And then once this is done, you can now get your hot water and thereby keeping your main heat source redundant. And of course, saving you a lot of money. So that's one way to do it. Secondly, for cases where you don't have the heating rods integrated in the water tank, you can have it in this format externally via a hot water flow heater. So this is implemented just as you can see here. So cold water comes in via the pump, and then the external heating rod heats the water, and then this water is now introduced into the main tank. So thereby also at the same time saving you the energy that you would have used for using the main heat source. Good. So in this case, we decided to do an analysis for a 4-person household with a 300 liter hot water tank and a 5 kilowatts peak PV system. So in this case, 5 kilowatt hour gives you about 150 liter hot water at 40 degrees centigrade. This is usually, by analysis, the minimum power supply you get on cloudy days. And of course, this would definitely go a long way to, serve your hot water requirements. But then on a very good day, on a very sunny day, you can get up to 17 kilowatt hour, which gives you 300 liter hot water at 60 degrees centigrade. So by so doing, using this production curve, we can see how the Ohmpilot, in this case colored gray, is implemented in your PV production curve to make sure that it covers for all the surplus energy that you generate, and then of course making sure that you pay less to the grid. So now let's talk about energy flow priorities. Yes, we've talked about storage, we've talked about input-output ports basically to control other heavy loads, and then we've talked about Ohmpilot. But these actually, the activation of these storage and load points or Ohmpilot actually comes in priorities. You can prioritize one over the other. So we're going to take an example of how you can actually do this. So let's take priority 1, for example. If you prioritize the battery storage, once you have surplus energy, the battery storage will be activated first. Now, if the surplus energy now becomes greater than the charging power, the surplus energy is now channeled to the Ohmpilot for hot water generation. Now, if the battery becomes full, then all the power is now channeled to the Ohmpilot eventually. Then if both storages are full, that is battery and Ohmpilot, then you can now activate additional loads, in this case, the air conditioner, heat pump, food pump, for example, through the digital input-output point, or feeding in the case where you can feed into the grid. So that's basically how it's done. And I have a snap shot of how this is done on your dashboard of your monitoring device. So you have them in priority levels. Here, as you can see, this is what I've explained. So if you don't want it this way, if you want to prioritize Ohmpilot, for example, all you need to do is to click on the up arrow here, then Ohmpilot comes up and takes first priority, and then the battery comes to second priority, and vice versa, of course, with all the other priority levels. So that's how you can actually set priority levels for surplus energy management. Good. So we now have a production and consumption without Ohmpilot. As you can see, in this case, you have lots of surplus energy here that are not utilized. And as you can see, the own consumption or self-consumption level here is 62%. But by the time we implement the Ohmpilot, you can see that it has been greatly utilized, and your own consumption level has actually risen from 62%, as was the case previously, to 99% in this case. So what are the advantages we get from heating with PV via our Ohmpilot? Yes, it's easy. It's easy to retrofit, and the maintenance is free. It's highly economical because it saves energy cost and, of course, protects your main heating system. It comes in with a low investment cost, because it requires only a few additional components to have it set up. And then, of course, and most importantly, gives an advantage to our Earth by having low emissions. In fact, during summertime, you don't have any emissions at all. So that's the end of my part of the presentation. But before I hand over to David, I would like to launch a poll, and I would please love you all to participate and send me your feedback. Yes. So the poll goes: which of the following surplus energy flow paths takes utmost priority for your respective regions? As we all know, these priorities can actually depend on the region where we are located. Some might prefer battery storage, some might prefer Ohmpilot, some might prefer activation of other heavy loads. So please, for your respective regions, which of these surplus energy flow paths takes utmost priority when, let's say, you want to program them in priority levels? So I would love to have your response in this case. I'm going to leave the poll question for about 10 seconds from now and get your answers. Oh, I can see that some of you didn't have the opportunity to choose. So we will from my response, please, you can put your answers in the chat box, and then of course that will be greatly appreciated. Thanks a lot for your answers. as I now hand over to David to continue with the presentation. David?
Yes, thank you so much, Cyprian and Mohammed, for your presentations so far. So I'm now going to be dealing with the remaining topics for this webinar, which we start off with the Gen24 Plus commissioning. And just to take our attendees today on the process of commissioning your Gen24 inverters. So the Gen24 commissioning, of course, the process is very easy. What I'd like to mention at this point is the fact that there is a slight of a difference between the Gen24 commissioning and the commissioning of the Snap inverter series, which most of our attendees today could be used to. So this is the front panel or the front cover of the Gen24 Plus inverter. And as we can see, this inverter does not have an LCD display. It only has two LEDs which communicate with the installer or the user to be able to know in which state the inverter is operating. So once you have done your cabling and you have finished up, you've mounted the DATCOM cover, which is this particular area here, and you've put on the DC disconnector in the on position. Then what you do is on the center, at the center of this LED section here, there is an infrared sensitive button, which you just push. And once you push it, this allows you to activate the Wi-Fi access point. So once you want to now activate this Wi-Fi access point, as I've explained before, you can see these two LEDs. So there's one to the left, which is what we call the operation LED. And there's one to the right, that is the communication LED. And this is the one that is telling you whether your inverter is connected to the internet, especially when you're doing monitoring, or if it's connected to your laptop or your phone when you're doing the initial commissioning. So this one to the left here is the operation LED. So it will tell you the status of operation, whether it's okay, whether it's on standby mode, if there are any warning, and therefore the LED is flashing. But not to worry, all these communication colors are interpreted and given step by step the way you can interpret them in our user manuals. So this is not something that you have to memorize. So by touching the center button, the one I said is an infrared sensitive button once, you are going to be able to activate the Wi-Fi access point of the inverter. And this is now the one that is going to lead you to the commissioning wizard of the Gen24 Plus inverters. If you touch it twice quickly, this allows you to activate the WPS function. And then if you are to hold this button here for longer than 3 to 6 seconds, then that allows you to quit the service messages. And also by the same action of 3 to 6 seconds, you can deactivate or activate the key lock. That ensures that someone does not accidentally start up, for instance, the Wi-Fi access point. So how do you do the commissioning for the Gen24 Plus inverters? There are two ways you can do this. Number one is using the smartphone app, the one that you can download from Google Play Store or Apple Store. And this is what you are now referring to as the Solar.stat. And once you now have this open, once you open the Wi-Fi access point from the inverter, there's an automatic connection between your phone and the inverter. So this is a very straightforward process of commissioning, the initial commissioning of the Gen24. The second alternative, how you can commission the Gen24 Plus inverters, is by using a web browser. So this is something that you can do on your phone, on your laptop, sorry. And this is available, of course, for every internet-ready device. We are talking about a laptop, computer, tablet, and the like. And same procedure would follow, that the first initial step is to open up the Wi-Fi access point by touching the infrared sensitive button once. And once you've done that, you go on to your web browser, and preferably Google Chrome. And once you open Google Chrome, you go into the tab for entering the internet IP address, or where you search your website, and you enter this IP address provided, which is the same for all Fronius inverters. And once you do that, this is going to lead you to the commissioning wizard of the Fronius Gen24 inverter. So there are two routes that you can take, especially when you are installing or commissioning your Gen24 Plus inverters using the browser. The first route is using a Wi-Fi connection between the Gen24 Plus inverter and your computer or laptop. So the simple process is as follows, that once you have opened up the Wi-Fi access point, you're going to identify the particular Wi-Fi or SSI ID from your Wi-Fi search area on your laptop. That is the Fronius, then the serial number or the pilot number ID for the particular inverter that you're using. And then the password that you enter once you have opened up the Google Chrome search is the 1, 2, 3, 4 up to 8. The only difference that you have to note is that when you're using Windows 10 operating system, you have to activate through the connect using security key instead for you to be able to enter the password and therefore continue with commissioning. And like I said before, once you have opened up Google Chrome, just enter this IP address, and then you're going to put up the password. And after that, that will open up the installation wizard for you. And once you have done, or you followed up all the steps, as we can see here to the right, you're going to end up with the very last step that you do the Solar.web configuration or adding your system into Solar.web. The second route, when you're doing the commissioning of your Gen24 through a browser, is to use an Ethernet connection or a cabled internet connection. And this is probably sometimes could be the case when you don't have a proper, let's say, Wi-Fi connection possible for many reasons. And therefore, the only alternative could be that you need to do this configuration or the initial commissioning using an Ethernet connection. So this, of course, we are talking about a Cat5 cable. And when you look at the pilot that my colleague mentioned is the data manager or the communication component for the Gen24 Plus inverters, it has a LAN 1 port provided. And this is the Ethernet port that you connect your internet cable. And once you do that, you connect then to your laptop. It could be going through a router somewhere or something like this. And once you enter this IP address, is slightly different from the one you enter for the Wi-Fi connection. Then this will not ask you for any password. Once you enter this into the Google browser or any internet browser, then directly this will open up the installation wizard for you. And just like before, once you have done or followed up all the steps to the last one, then you end up in the Solar.web section where you add your system in Solar.web. So when you're doing the configuration of the Gen24, the initial commissioning, there are several sections that you go through or you should know about. There is a network connection area, then there is a product where you configure your product, and also the very last step where you commission your system in Solar.web. So the network connection, this is where you assign your customer password, and then you go into the product where you assign a technician password. And the technician password has a lot of capabilities because you can change quite a number of configurations with the Gen24 settings. And then the very last one is the Solar.web addition, where you can also, like I said before, add the system into Solar.web and also be able to classify which users have which rights for the system in Solar.web. So as you can see here, we have the classifications of what each section of the password allocated for different users can do. We have a guest section, we have a customer section, as well as the technician section. So the guest section is you don't actually require any login data. So you can just see this automatically once you have a connection between your inverter and the laptop. And you have no possibility to do any commissioning of the inverter or the network. So this is just like giving you an overview of how the system is operating at any one particular moment. Then you have the customer section where a password assignment is given in the commissioning wizard. And this therefore can allow the customer to do a few modifications into the system, especially the network settings. And this customer section will not allow access into critical network parameters. So the next stage is for the technician setup, where you also get a password assigned. And the technician section will give you unrestricted access to the inverter settings, except the grid code settings. And for the grid code settings, if you do require to access this area, we of course do require that you get an access code from our tech support in Austria. And to be able to sign a declaration that you fully understand the implications of changing the grid code settings. Because if you are to interfere too much with the grid code settings, this could have a very negative effect on the operation of your entire system. So when you're doing the connection now between the Gen24 inverter, whether by Wi-Fi or Ethernet cable, you come into this particular area where you see the dashboard. This is the dashboard of the installation wizard of the Gen24 Plus. And you can see all the menus that you can follow depending on your class level, whether you are customer or technician, or even a guest, to be able to do several configurations into your system. So this is a very straightforward process. It does not need a lot of explanations. I think my colleague Cyprian has already talked about the energy management and how this can be done, but pretty much the rest of the configuration is straightforward in this configuration wizard. So once you've done the configuration and the initial commissioning of your inverter, you need to be able to bring it into Solar.web. Something I should mention here with the Gen24 Plus inverters, we do require that you maintain the latest software versions for that particular inverter, for Gen24 inverters, to make sure that all your warranties are in full effect. So that is one of the conditions that will be there with the Gen24 Plus inverters. So always please make sure that once you have done your system initial commissioning, you always bring your system with the Gen24 into Solar.web. So there are two ways to bring your system into Solar.web. Number one is to create a Solar.web account. And this can be done also using the Solar.startup on your mobile phone, or this can be done in the Solar.web desktop version, just like I've explained before. And you go there and create an account, also a very straightforward process by registering a few credentials that the account is going to be monitored under. The second way to bring the system into Solar.web is when you already have a Solar.web account. If you have an existing Solar.web account, you're not going to require an additional account for every other system you install. So one system can monitor as many systems as possible. And then all you're going to do, whether it's by Solar.startup on your phone or the Solar.web desktop version, is to add a PV system. So you see this cross here also for the Solar.start. You just click that and it's going to allow you to input the particular details of the system that you're going to add into Solar.web. So once the system is in Solar.web, of course, now it means that you have the pilot configured properly, and therefore the pilot is going to connect to the internet. It's going to collect all the data from the inverter regarding system performance, and this is to do with the production and consumption, and then communicate through the internet into Solar.web for visualization. And this visualization can, of course, be done also for all devices. It can be done on your phone and also your other internet-enabled devices, your tablets, your phones, and so forth. So all you need for monitoring and communication of data from the Gen24 inverter is a stable internet connection between the Gen24 Plus pilot and the router. So once that is established, then there's going to be automatic, let's say, forwarding of data into Solar.web from the pilot into Solar.web. When in Solar.web, it's not just a monitoring platform, and this is something that we would like to highlight for our attendees today and our installers. There are quite a number of things that you can achieve in Solar.web once you have your systems there. And number one, other than just monitoring, you can do quite a number of simulations to be able to have a better management of your system. So today we are talking about energy management solutions with the Gen24 Plus inverters. And using the Solar.web, you can simulate whether it's possible to retrofit an Ohmpilot into an existing system, or also if you can retrofit a battery storage into your system. As already mentioned in the beginning, you can have a system with a Gen24 Plus inverter where you want initially to use only the PV point as your backup power source. However, depending on the excess amounts of energy available, once you've done your analysis in Solar.web, you can decide at a later stage based on this simulation that yes, I can add this amount of kilowatt hours of battery storage into my existing system. So when you go into Solar.web, you're going to follow a very simple process. If you have already a system added there, you go into your system, you access that system. click onto analysis button, then you go to simulation, whereby once you click on simulation, this particular button here, you're going to be able to input quite a number of details that are required. The most prominent information that you need to provide is how you are heating your water. Is it oil, gas, air heat pump, or geothermal, pellets, and the like? And then you enter what is the size of the boiler or the water boiler that you're going to be working with. Is it 150 liters? Is it 200, 300, and so on? And then energy consumption and the like. So once you now click on simulate, Solar.web is going to be able to tell you how your system is going to be able to utilize the available excess energies in the system. Also, similarly, you can also do a simulation for battery storage, but you can see here that you are going to require a smart meter in conjunction with your system. So, and this is also something that is very important to stress out. Because the smart meter gives the overall system performance. This you're talking about consumption of your energy production and how much therefore is the balance of power or energy you have in the system. So without the smart meter, you're not going to be able to do a battery simulation. So a similar process will be followed, that you access your system in Solar.web, then you go into the analysis area of that particular system or in the menu section, and then click on the battery simulation. Once you do that, you're going to be able to simulate quite a number of things. So because of time, you're not going to go into Solar.web, but I would have love to show you a live overview of how this is done, but it's a very straightforward process. For all those who already have operating accounts or working accounts with Solar.web, please use any of your existing systems and go into Solar.web. And okay, let's continue. Apologies for the network issue on my side. So like I mentioned before, the solar configurator is what now allows you to design your strings and also the batteries to be used with the Fronius GEN24 Plus inverters. And this is a tool that is, of course, available for free with the Gen24 inverters. So you don't need to pay anything for the solar configurator. So this is embedded in Solar.web and can be used for those who already have existing Solar.web accounts, and also those who do not have Solar.web accounts. If you go into Solar.web and you type Solar.web in your web browser, you're able to access a demo account for Solar.web, and also in this demo account, you can use the solar configurator for simulating your systems. So of course, now the Gen24 inverters are now included in the solar configurator. And all you need to do is, once you open the solar configurator, is to specify, as we can see in this screenshot here, the number or the type of module that you're going to use, who is the manufacturer, which is the manufacturer of this module you're going to use, and then select what is the wattage of each of the modules that you're going to be using, and the quantities and so forth. So the solar configurator is going to be able to work out what is the power of that particular array that you're designing. Then you select which country is where the system is going to be installed, the series of the Gen24 inverter that is to be used, whether it's a Symo or Primo, and then you specify which exact now model. Is it a 6 kilowatt, 8 kilowatt, or 10 kilowatt? On the last section here, you put in the project name, but most importantly, this will allow or show you the compatible BYD batteries for that particular Gen24 Plus inverter. Also, there's a section that asks you your load profile. Are you unemployed or a kind of work from home kind of scenario? And in an employed scenario, therefore, you might be having a lot more excess energy because you do not have so many appliances running during the day, and therefore that makes a perfect scenario for you to be able to store up excess energy in the battery system. So the solar configurator, of course, we do recommend it very highly, regardless of which other configuration tools you're using, because this allows you to optimize your string design for all Fronius inverters. So the string design will, of course, be affected by things like what is the minimum and maximum temperatures, and also what are the maximum and minimum inverter ratios that you would like to use. So the use of the solar configurator is something that we highly recommend to ensure that your string design, as far as the lengths are concerned, are optimized. Now let's look at the Gen24 Plus retrofitting, because now the Gen24 gives us a very nice possibility, or very good possibility, to be able to retrofit this kind of inverter into an existing system. So in a typical setup, we could start like this, where you can have, like already discussed, a Gen24 Plus inverter connected to your PV array. And then this is connected into a battery storage system, and this is taking care of your load requirements together. Also in connection with the smart meter, which we said is a prerequisite component when you're using the Fronius Gen24 Plus inverters. The next step could be in a situation whereby you have an existing installation, PV installation, with another series of the snap inverter series from Fronius, and therefore you do what we call AC retrofitting into the system using a Gen24 Plus inverter with storage. So this would allow you to, based on this analysis you've done on Solar.web, you've seen that there is quite a bit of excess energy. And you've asked yourself this question: what can I do with this excess energy? And one of the things that you think you could do to increase your self-consumption ratio is to add a battery storage in the system. A battery storage, like I mentioned before, is not going to be compatible with the snap inverter series from Fronius, and it can only be used with the Symo hybrid and the Gen24 Plus inverters. So it's very easy to retrofit in an AC coupled fashion the Gen24 Plus inverters into a system existing with other Fronius snap inverters. And this gives you a lot of flexibility in terms of self-dependence and self-reliance as far as energy consumption is concerned. And you can extend your usage of PV power even into durations when, especially at night, you have no PV power being produced, and make a lot of energy savings as a result. So one thing I should mention here, however, is that once you do an AC coupled installation with a Gen24 Plus and other Fronius snap inverters, if there was to be a grid failure at this point and the Gen24 needs to enter into full backup mode, it's going to increase the frequency in such a manner that the other Fronius inverters in the installation are going to switch off. So this is going to ensure that there is a perfect harmony between the powered loads and the amount of energy that can be supported from the Fronius Gen24 Plus inverter. So for further information, I believe my colleague has already shared out a handout in the dashboard of the Go to Webinar section where you can download it. So we do encourage you to download this information regarding the Gen24 Plus inverters. But also we have a lot of information on operation and installation for the different Fronius inverters in our homepage. So you go there to the downloads section and you can download also a lot of useful information from the Fronius website. Also, all our YouTube videos are available for your use. All the webinars that we do are mostly listed also in YouTube. We have a specific YouTube channel for the Sub-Sahara Africa region, and you can access it using this link provided. This link is going to be shared together with the webinar recording for today, and you're going to be able to access these videos at your own time. For further information and how to contact us, we do encourage you, if you encounter any difficult scenarios or if you have new inquiries on possibilities of using the Fronius inverters and other solutions, to make use of our contact details, contact any of us depending on your region for South Africa, West Africa, or East Africa. And we are very happy always to talk to you and discuss with you different kind of scenarios for different applications with our products. And with that, we've come to the end of our webinar for today. I would like to take this opportunity to thank everyone to be with us today. And we hope that you have gained a lot of useful information and insights for energy management solutions with the Gen24 Plus inverters. And we do look forward to hosting you again for our series of other webinars that are upcoming, starting also next week with different topics. So for now, we thank you very much and wish you a good rest of the day, and goodbye.